challenging.
All right, so we have not only the chain rule, but we also have
The product
product
rule
rule.
in there.
So we have to do the combination of both. So if we think about really quick what the product rule is, it's just uv prime plus vu prime.
Right.
Okay, so let's go ahead and dy dx.
Super. So,
U is this whole term.
right. So,
This is u, maybe I'll write that there, and this is v.
all right. So let's just write down that big ugly thing.
2x plus 1 to the fifth. Now we have to multiply it by the prime,
By the derivative. So,
a derivative of v.
right. So now we pull the 4 down. 4 times x cubed minus x plus 1.
Take 1 away from the power, multiply by the inside derivative, so
The chain rule kicker. 3x squared minus 1.
okay. So now we've done this part so far.
Right.
Now we have
Plus.
to add. I'm going to move down here to have save more space.
Mm-hmm.
So x to the third minus x plus 1 all to the fourth, that's our v,
Right.
times u prime.
So I pull the 5 down. 2x plus 1 to the fourth, because we subtract 1 from the power, times the inside derivative, which is just simply 2. All right.
Okay, since it says do not simplify, we're just going to stop there.
Hooray. All right. Next, using our things to find the equation of the tangent line at that point. If we're going to find the equation of the tangent line, we need to find the slope. Slope of the tangent line is derivative. Hooray, derivative.
Okay, so first off, I mean, we can look at this and we could do the quotient rule, but you know what? It's much easier if we just rewrote this function to be 8 times 4 plus 3x to the negative 1/2. And all this stuff just kind of becomes intuition. The more you do it,
Right.
the more practice you have.
Yeah, and doing these little small changes make it way easier. Getting rid of roots and making them, or surds, however you like to call them, and make them into exponents is always a good call when you're dealing with derivatives as well.
So if we're going to write an equation, the two things we need are slope and a point. We have point, but now we need the slope of the tangent line. So finding the derivative.
Okay, so we start with our power rule. We pull the negative 1/2 down.
All right, so we have negative 1/2.
Times the 8. And then 4 plus 3x to the power of...
Minus 1 from that, so we have minus 3/2.
Okay.
Multiply by the inside, just 3.
Which is 3. Okay.
Okay, that's a big, long, ugly equation, but since we know it's going to be at 4/2, we can go ahead and plug in 4 for x.
Right,
Wanna do
because
that here?
because right now we have the slope of the tangent for any given point on that curve. If we plug in x equal to 4, then we'll get the slope of the tangent at x equal to 4, that one specific point.
Yeah, so really we're just finding like, okay, anyways. So now this is just negative 4.
Yep, let's plug our 4 into it.
4 plus 3 times 4,
Mm-hmm.
all to the negative 3/2 times 3.
Okay, now let's keep simplifying. So we got negative 12, because the 4 and the 3 together.
Okay, 4 plus 12, all to the negative 3/2.
So we get negative 12 times 16 to the negative 3/2.
Well, let's talk about what 16 to the negative 3/2 looks like, actually.
Right.
To get rid of that negative, I can just rewrite it as 16 to the 1 over 16 to the 3/2.
Right. And then if we do the 1/2 part of it, that means the square root of 16.
All right, so the square root of 16 we all know is
4.
4, and we still have it to the third power.
Right. And 4 to the power of 3 is 4 times 4 times 4, which is 64.
All right, so now we have negative 12 times 64.
Right. Oh, 1 over 64.
Oh, thanks.
Okay, and so now, if we come along and simplify that a little bit, we can divide both by 4, so I get negative 3 over 16.
And that's just telling us what our slope of the tangent line is.
Right, and this is at the point 4, 2.
And if we go ahead and use point slope form, write our equation. we have negative 3 over 16 times x minus 4 equals y minus 2.
Right. If we want to simplify that, we multiply everything by 16, both sides of the equation.
So now we have 16y minus 32.
Distribute the negative 3.
And if we wanted to write this in general form, maybe we just move over our 16, so we have minus 3x minus 16y. Move over our 12, this becomes a minus 12, so altogether
Negative 44.
negative 44.
And let's get rid of all those negative signs to
Oh,
make it
yeah.
look all nice.
Okay.
I'm surprised you didn't suggest that this time, since you like to make it all nice and tidy.
There we go.
Okay, there's our tangent line at the point 4, 2.
All right. Next one.
All right, last one. Hold on a second, Miss Flynn. Where's the function? There's no function.
There isn't, but we have all these points that hold true for that function.
Ah, okay. So it's just kind of general in terms of any function that has these conditions. So I know w then at x, let's say, is equal to u at v at x. Because that's the composite function there, right?
Yeah.
And I'm asked to find, at the end, it says w prime at 0.
Well, let's first just start off and find w prime of x.
Well, that's a good idea.
All right, so w prime of x. Oh, this is using our chain rule.
Right. So we
So,
just apply our formula. So it's u prime
Of
at
vx
v at x, yep, times v prime x at x. Okay, so now we want to do it at 0 though, right? So let's change all our x's to 0.
All right, so we're going to find the derivative at 0. So that means this is going to be u prime v of 0 times v prime at 0. Oh, this is just becoming more and more easy.
Okay, so let's just plug these in. If I look at the top, I want v prime at v at, or u prime at v at 0. V
What's
at
v
0.
v at 0, v at 0. Oh, 2.
2. So that's 2 times v
v prime is 0. v prime is 0. Oh, 5.
That's 5.
Okay, well now we can go a step further. Do we have any u prime of 2?
Well, we do.
Yay.
Yay, it's 4.
Times 5?
And so
20.
we get 20.
Easy enough.
There we go. Great.